I want to make a lame joke like chi squared. Yeah. Yeah. Except for I'm going to start with the two proportion test first. So I'm going to take you through how to do all three versions of the two proportion test on Minitab Express. So some of the data I'm going to use is, oh my God, what is that sound? My phone went off for a second. Sorry about that. I muted it. Anyway, so what's going to happen, and I'm not going to be able to erase that, that sucks, is this first example I have summarized data, so I'm not going to be using the data that is attached with this document in this folder. I'm going to be using it later, so you'll notice I have a nice clean, fresh, data sheet over here for doing my testing. So there's two places you can find the two proportion test on Minitab Express. The first one is this to sample button. If you click on it, come on, there she goes. You'll see the proportions test down here at the bottom. If you don't like that, the other place you can get it is if you go up to the top and you have your they call this not split screen view, I think is what it is on a Mac. This might have a different name. I'm so sorry. I'm not as good with Macs. Although I bought one, so you think I'd get better by now. I mostly use it to watch Netflix and play Sims 4. Anyway, so if you go and hit the statistics button, you'll see a two sample inference option. Down at the bottom again, you'll see proportions. So there's two places where you can get it on Express. I'm going to mostly use the two sample button because I like it. And I also like the pictures. So I'm going to hit this two proportions option and it's going to bring up this menu. Just like with 18, there's a drop down that you can choose. And in this case, I am going to have summarized data. So with this question, you'll notice it's like, hey, smokers and non-smokers, what's your opinion? Should the federal government have a tax on cigarettes to help pay for healthcare reform? So what's interesting about this question is clearly smokers and non-smokers are going to have a difference of opinion on this, but you want to know, is that difference statistically significant? And that's what this is going to do for you. So since we don't have the raw data from these 800 people that were telephone surveyed, what we have here is a summary of their results. So one thing to keep in mind when you're doing this, remember, number of events is always the thing you're interested in. So we counted the number of people who said yes. That's going to be, and I'm going to have sample one be my non-smokers. That's completely an editorial choice, not something you have to do. 351. And in total, there were 605 in the non-smoking group. Ooh, not 606, 605. And in particular, notice P hat 1, the one for non-smokers, is exactly this. And notice it's like numerator, denominator, numerator, denominator. All right, let's get those smokers in there. So out of the smokers, only 41 of them were in favor of the tax. And sorry, I hit the tab key to bring me to my next one because I thought it'd come down, but it went over. And there were 195 of them that got asked. That's the number in my sample size. So again, it's always event, thing I'm interested in, over number of times I tried. So number of times you tried might be a sample size, might be something you repeat in an experiment, but in general, it is always the larger of the two. Let's check our options to make sure those are set correctly. All right, and difference not equal to 0. I am just looking to see, does it differ significantly? So yes, not equal to is what I want. Yes, we're estimating the proportion separately. I don't care about the confidence level because I'm not doing a confidence interval with this one. Let's go ahead and hit OK. I will still look at the confidence interval because I always do with difference tests. All right, so sample 1, sample 2, and it always is going to do sample 1 minus sample 2, so just be aware of that. So in particular, if you're going to do this with summarized data, I usually will write a little 1 next to the one that's going to be my group 1 and 2 next to group that's going to be group 2 so I can keep track of it. Let's take a look at that estimate for the difference. So when you look at the confidence interval, you notice it's always positive, which means the one that was being subtracted from, so P1, where the non-smoker group, is bigger than the smoking group. And yeah, your p-value reflects that. So in particular, be careful with this because Minitab Express likes to report two values for this, and I just looked at the wrong one. We are using the normal approximation because it's the one that goes with our test statistic of z. Don't worry about the other one, we're never going to use it. Fisher Exact is just a slightly different way of calculating that p-value for the same z or test statistic. So since my p-value is small, I'm going to be rejecting my null hypothesis, which was that my proportions are the same. So it looks like, yeah, my smokers do disagree in whether or not they should be taxed to help pay for healthcare reform. So I'm going to say there is significant evidence that the proportion of smokers and non-smokers who support a federal tax on cigarettes. Oops, that's not an I. Is different. Probably should have put different somewhere else. Wasn't thinking ahead. There is a significant difference. Yeah, that would have been better. Oops, too late now. If you want to, you can include how big that difference might be. You could say that non-smokers prefer the tax somewhere between 30 and 44% if you want to round like the devil and make it like really rounded. You probably should use more decimal places than that if this is real research. Just saying. Because it's always positive. You can tell who's bigger. We usually are talking about who's bigger versus who's smaller. All right, so I am actually done with this one, so I'm going to close it and not save it because I do not need this guy. Delete. All right, let's talk about some chocolate. So for test number 2, I'm going to be doing this on raw data. I'm going to ask myself, amongst men and women, does it appear that they like dark chocolate at a different rate? Because, or sorry, not dark chocolate, white chocolate, the grossest of all chocolates. We want to see, do men or women seem to prefer white chocolate more? Is there a difference between the two of them? And one of the problems here is exactly one of the things I was describing in your notes. When it comes to the 2 proportion test, I must have only 2 options for the thing I'm making my proportion from. And in particular, when we look at the preference column, there's 3 options. There's dark, the only chocolate's real chocolate, milk, which is the sissy chocolate, and then white, which is not really chocolate. It's just somebody's idea of a joke. Anyway, so what I'm going to have to do first is recode the preference column to track who said they liked white chocolate. So recoding in Minitab Express is easiest done through the data menu, recode, and then to text. So I'm going to make a new column using preference. I want to take these and turn them into no's, because no, no, no. And then white is going to be yes. I simply chose white chocolate because, again, a lot of people don't like it. Yep, so this is just going to create me a new column at the end of my document. So there's my new recode. Always double check your recode to make sure your no's line up because we want them to look the same so that Minitab thinks they are a part of the same value. All right, now that I've got this set up, I'm moving on to step 2, where I'm going to make my proportions. So these are going to look like exactly what I described. I want to see the proportion of white chocolate likers amongst the females is the same as the proportion of white chocolate likers amongst the males. I don't think there's any difference between them. Remember, hoes are boing, they're statements of sameness or equality. And so for my ha, I'm going to say they're not different. And I'm writing female first simply because the first person in my data is female. It's not a personal preference in any way, shape, or form. I like how I pluralize this sometimes and sometimes I don't. Let's see. Insert. Come on. I want to insert a not equal to. Advanced symbols. Why? Why is this taking? I'm gonna have to cut this whole part. Please don't make this video 30 minutes, my Mac. There's my not equal to. Dun 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 dun. Whoa, that was weird. Close. Go away. Alright, let's perform this test. I'm on step 4. Whew, about time. So, we're going to go ourselves, hit the 2 sample button, get our 2 proportion action on. I want to throw, as my sample, I want my white chocolate lovin'. That's my sample stuff. And then sample ID, remember this separates and creates your 2 groups. It's going to take and create my male and female group. The event I'm interested in is yes, I want to have them like white chocolate, so there's that. This is one thing that's kind of nice about Express versus 18. With 18, you don't get a choice, it's just going to pick for you. That's just the way it is. Notice this is the proper one because both my samples are in one column and then my ID column is making my 2 groups that I'm comparing. Anyway, let's check our options. Everything's looking good there. And again, difference, you only want to change this if you think there is going to be... My phone's going off again. That's so embarrassing. If you think females is going to be greater than males, or based on the question, they want to know if you have an increase or decrease. So I'm not going to mess with this unless I absolutely have to. And right now I'm just checking for a difference, so not equal to is exactly what I want. Let's hit OK. Perform the test. All right, it's choosing yes and female, yes and male. So group 1 is female, just like kind of my order is female then male. I mean, obviously, if this had done the other order and it really mattered, I could just switch these 2 so that it matches what Minitab had. Don't forget that trick because you totally can use it. I performed the test. Now I need to report my test statistic. I'm going to do that in bright red like I usually do so that it's noticeable. And for me, my z value is negative 1.31. And then my p-value, bright red, kind of big. And, oh, my p-value is kind of big, 1.885. Ooh, okay. Resounding no. It looks like, oh yeah, because my confidence interval has 0 in it. Yeah, there's no difference between these two. Okay. Let's go ahead and write that. Oh, I'm going to fail to reject my hoe. It looks like, men and women both like white chocolate at about the same rate, or at the same proportion. The sample evidence indicates, I don't know why I'm writing this different all of a sudden. I want fancy words. That the proportion of people who like white chocolate is the same for both men and women. Yep. So if you wanted to tackle the is it the same for milk chocolate and dark chocolate question, you need a more powerful test. One that does that is the homogeneity test, which is one we're going to do next week. Yep. That's about the breaks. All right. Let's say, hey, I want to know how different are they? They're not different, so I don't know why I included this. Let's calculate the 95% confidence interval proportion of the difference. Write your interpretation of your inclusion. That's a typo. That should be interval. Using complete sentences and relating it to specific content. So making sure that you're talking about what this is. So I'm going to say that it looks like men like dark chocolate a little bit more, up to 13%, and women like it more, with their difference being up to 2%. So this is going to be hard to write, so hang on to your stuff. I didn't make it red. Oops, bad teacher. We are 95% confident that the difference of proportions difference of the proportion. I want the in there. That's the word I'm missing. That feels better. Sorry. I knew something was wrong there. The difference of the proportion of women who like white chocolate and men who like white chocolate can be as much as men liking it up to 13.28% more, or as low as women liking it up to 2.6% more. So it should show you that on one end, one's higher than the other. Yeah, so it's women who are higher on one end, men who are higher on the other. Ugh, that just indicates to you that, there is no difference. And usually when I run into this kind of situation, this is exactly what I'll do. I'll write that part because that's the exact interpretation of what it means. And then I'll include this. Since 0 is in the interval, 0% is in the interval, they do not significantly differ. I sound kind of quiet, I just realized. That's kind of a first for me. Yep. Believe it or not, in my family, I'm considered the quiet one. Shocker, right? All right. Awkward. All right, we're going to do our next raw proportion one, which is let's take a look at raw data where they're each in their own column. So I am done with this data. I'm going to close it and not save it because I don't need it. Woo, goodbye. Okay, no, I don't want to save. Go ahead and delete. Bye-bye. All right, so over here I have some data from the early days of Northwood University when they were comparing online classes to face-to-face classes, or one where you're taught in person. Yep, they usually call these traditional courses, but face-to-face is the more modern name of them. And what they were keeping track of is grades, A, B, C's, and D's, and F's, unfortunately, And so all I did was code that data so that we were keeping track of only A's, because that's something we can actually do. And this is very early on in the program. You notice that I have more face-to-face students than I do online because this was only one online class. What we want to see is if I compare online to face-to-face, do we have more students that get A's in online or not? So that should indicate to you that my hoe here is actually going to be a little bit different from what we've seen previously. So my hoe is actually, hey, I think the proportion for online is going to be greater than the proportion for face-to-face. Now I'm going to rephrase this a little bit. So I'm going to imagine taking the proportion for face-to-face and subtracting it to the other side so that I get a 0 on this side and the greater than sign stays the same. And you can do that because subtracting does not change signs, which is the other reason why this is kind of nice. So I'm just going to steal this for a second. Yep. So then all I have to do for the ha is just, oops, I always forget the delete key on a Mac is in the same spot as the backspace, but doesn't do a backspace. And that's actually the alternative hypothesis that I've described there, not the hoe. The hoe is just, I think there's no difference between them. So I've got this set up, so I'm finally going to do a greater than. And notice in particular I'm doing online minus face-to-face. I'm going to have to be very careful with my order in my 2-sample test on Minitab. So I'm going to click over here to 2-sample test, go down to proportions. All right, now I don't have this situation where everything's in one column and I have to separate them using another variable. I do have this situation where each sample is in its own column. Go ahead and click on that guy. All right, so I've got online and face-to-face, and you're up to the choice of who do I put first. Well, when it comes to how Minitab calculates things, it always puts sample 1 minus sample 2. So since I put online minus face-to-face, I've got to put online first to have this match my ho and ha. All right, and then it's going to ask me what event I want. I want yes, because that's counting my A's. Let's check our options. There it goes. I got to be careful here. So notice it's changed this up. It doesn't say sample 1, sample 2 because it's using the name of the variables I'm using. So it says online minus face-to-face. So that's exactly what I want. Double check, make sure it matches what I've got over here. And then I got to change my difference that matches my alternative hypothesis. I want to see if it's greater than 0. And now I'm good to go. Let's hit OK. There we go. So yes, yes, online, and then face-to-face. So online minus face-to-face. Looks like my difference is fairly small. Let's see if it's significant. Ooh, it's not. Look at that p-value. It enormous. Okay, so it looks like my alternative is not the one that I have supported here. It looks like my evidence is pointing towards my null. So my evidence seems to suggest that online and face-to-face get about the same number of A's. So I'm only looking at A's here. If you wanted to ask a question, this same question about B's, C's, D's, and F's, that would be the test for homogeneity, which checks to see are the portions the same amongst multiple groups. So, you know, things to look forward to. We're doing that with the chi-squareds later. You know, good things. So I want to say there is, now let's just say this sample evidence suggests that the proportion of A's is the same for both online and face-to-face courses. Which is good, because you don't want to have them be different. Yeah, because my suspicion is that, oh, is the online class easier? I'm getting a lot more A's. I don't know. Evidently this is a no. I believe this was a finance class, though. Fun fact. Not a math class. I don't remember. I'll have to go back and look. Anyway, so I am done with doing the proportion test. I'm going to hit a couple enters here just to make all my chi's go together. So I'm going to be moving on to doing the chi test. So once again, I'm going to open a new fresh and dandy Minitab so that I don't have anything extra on there. Because this time I'm going to do some stuff and I have no data. So first up, let's calculate some chi-square values. So this is some of the probabilities and p-values I was doing in class. I'm going to show you how to calculate them on Minitab. So I'm going to first look in A at doing one that has degrees of freedom 3, and I'm going to look at a chi value of 4.467. I'm going to click over here into Minitab, and so to do this we're just going to go up to probability, distribution plot. I'm going to choose display probability. That's the only one we ever use. So once again, that was probability, distribution plot, display probability. I'm going to do that again in a minute just to make sure you keep track of this. So I don't want the normal distribution. I now want chi. So if we click on this, you'll notice it's in alphabetical order. So it's near the top. There's my chi. It asks me for my degrees of freedom. In this case, for A, it's 3. And then I have a chi value, which is along the x-axis, so it's a specific x value, and it's set on right tail. We only ever do a right-tailed probability with a chi test, so I'm never going to change this. 4, 4, 6, 7. There we go. So again, right tail only on chi. That's going to be true for f when we do it later. I don't have to worry about which direction I'm going at all. It's always right. Yeah. Chi is always right. So there's my distribution. It's kind of lumpy, right? It's got that long one-sided tail to it. And that probability is pretty big. So if this was used to do a test, I'd be failing to reject my hoe. Let's copy our graph over. I have one of the magic mice, which I think is a hilarious name. So for me, I could actually do a right click on mine by just clicking slightly over to the right side and getting this on my Mac. I believe if you hold Command and click, you get the same thing. Nope, I'm wrong. It's Function and click. I am still wrong. Control and click. There it is. I totally know what I'm doing. Just good. Anyway, now let's paste it. Which is definitely Control and then V, by the way. My self-loathing is high today. Okay, so let's go ahead and do this again. So the reason I picked this to do is I really wanted you to see that yes, the degrees of freedom makes a big impact. So in particular with this one, you should notice from what we saw in class, the degrees of freedom is 13 and my chi is 11, almost 12. And you know that the peak is going to be at about, well, 2 less than this is going to be at about 11. So this is going to be huge. Just a reminder, going back to degrees of freedom 3, this peak should be about 1. Look at that. Does that look like it's about 1? Yeah. Alright. Maybe you believe me, maybe you don't. Anyway, I like it when you repeat stuff on Minitab Express because you can just hit this Make Similar button. Look at that. Alright. My chi needs to be a 13. I need to change my value. 11.87. Why am I singing? Let's just see what this looks like before I drive one of you crazy. Oof. Okay, so I know I've got them sitting next to each other. I was hoping they'd be about the same size on Word as they did on here, but they're not. I'm hoping you see that this one does look a lot more normal than the previous one. And don't fool yourself into thinking that this one looks a lot bigger than the other one. They have the same amount of area. They're both area 1. How you can notice that is the top of the peak of this one is just above 0.8, which on this guy would only be like here-ish. So like this one's not as tall. You know what I'm saying? It would look lumpy on this graph. Like short and stumpy. That's the word I was looking for. Oh, let's copy this graph over and paste it in the wrong spot for fun. Just kidding, we're pasting it in the right spot for fun. There it is. So for this one, the probability is even bigger, just like I suspected it was going to be. So, yep, it looks like that would be something where your hoe would totally end up being failing to reject. If this was your p-value. All right, let's look at how to do some goodness of fit testing. So I'm going to show you 2 different ways to do a goodness of fit test. One, I tried to get creative, and then the other, I didn't get creative at all. Welcome to the in-creative one. We'll end on creativity for funs. So, in particular, for the chi-square goodness of fit test, this is a very typical usage of it. Historically, in a metropolitan area of the northeastern United States, I believe this was in upper New York, if you were wondering. They kept track of the type of property they had in the area that was selling for, I think it was a real estate agent. Yep. Anyway, so historically, 15% was condos, 30% were townhomes, 40% were single-family homes, 10% were commercial, and 5% were land. Obviously, over time, things like this change. So what we want to do is we want to look at a sample of what's happening now and what recent sales were and compare it to history. And this is a very typical use of the chi-square test. So I'm going to go ahead and type my data in. This is also a fairly typical like textbook question or just anybody reporting data question. If you notice, people tend to be stringent about how they put their tables in so they take up less space and are less confusing because of it. But unfortunately, Minitab only does stuff vertically. So we got to write this going upsy downsy instead of acrossy like that is. So I'm just going to use the word type for type of property. Boonk. So I've got 5 types: condo, I always want to type condors. Townhouse. Homes. Ooh. Great Lakes. Commercial, which I have a hard time spelling. IAL? That looks wrong. Oh well. Land ho! I have just made the same joke in both videos. That's awesome. Anyway, so I want to keep track of my frequency over here, or how frequent or how many of each of these there were. So there was 89 condos, 121 townhomes, 78 homes, and then 25 commercials and 12 lands. All right, now that I've got these in here, I can start getting ready to do my hypothesis tests. So, you can do the hypotheses for these the same way we would have done in class. If you want to write them symbolically, it would be, hey, condos, the proportion for condos is 0.15, the proportion for townhomes is 0.3, the proportion for homes is 0.4, and da-da-da-da-da for the rest of them. So, and remember, it needs to be all of them being the same as what we've seen historically. I'm going to write this with words because I think it's easier. So, the proportion of proportions, of current sales match the, I mathed, the historical values. Done. That's it. Isn't that easy? I like it. Okay, and then for the remember, you'd have to write out, these are different. Maybe it's condos that's different, homes is different. Maybe it's 3 of them that are different, or 1 of them that are different, or 4 of them are different. Ugh. What we want to write is we want to write at least one looks like it's going to be different. At least one proportion differs from, I wrote form, from the historical values. I wrote values in there, but I really should say historical proportions, because that's what these are. That's more accurate than values. Values is too general. In fact, in general, steer away from the word value. It's like using it for everything. What are you talking about? Because I don't know it. Anyway, let's Minitab this. So let me click over here. So everything they do with Chi and Minitab is in the tables button. So you'll see the first option here is, hey, do you want to do a chi-square goodness of fit? Yeah, I do. All right. So my categorical data is in a column. It's in my frequency column. And I don't want to do equal proportion. I want to do, oh no, wait, it's not in a column. I am wrong. I'm doing this wrong. Oops. So if you have all of your data in a column, like written out, like condo, 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 townhouse, 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 home, 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 like the number of times that those appear, that's the one you want to use. Mine is already in a table, so I need to change this. I have summarized data in a column. Sorry about that. I want to put observed counts in there. That's my frequency. You counted them up yourself. And then my category names is type. And I want to tell it what kind of test I want to do. I'm not doing equally proportion. Equally proportion would mean I think they all show up equally amount with each other. I actually have specified values here, so that's what I want to use. I'm going to do it based on historical counts, and it's going to ask you what you want for your counts. And you can actually put proportions in here, so 0. Even though it says counts. I know, it's a little confusing. So for commercial, it rearranged it for me. This is one thing that gets a little annoying with Minitab Express, but also is organizationally pretty in my mind. It reorganized this. It's not in the same order I have down here. It has commercial first because it put it in alphabetical order. Not every version of Minitab Express will do this, but watch out for it. I forgot about it, so I almost put the wrong thing in here. So commercial properties is 10%. I almost did this wrong. That would have gone really badly. What? Proportion based on historical count. Yeah, 10%. Greater than or equal to 1. This is doing something weird. This did not go like this. Maybe 10%? Nope. Okay, this isn't going to work. Hold on a second. I have to pause this and figure out why it's going wrong. Okay, I screwed up. You have to specify proportions, which is exactly what I said, and then I clicked on the wrong one. I love me when I do things right. I just need one day where nothing goes wrong. Oops, I missed my decimal point. This is going to go really well. Sorry about that. Condos, where were condos? 15%, 0.15. All right, homes, 40%. I have to really read carefully while doing this. Land, that was 5%. That one I happen to remember. And then townhomes, it's got to be like 30. All right. So some of these I wrote weirdly without the decimal point being in weird spots. it won't matter. Okay, next up, let's check our display. So I'm sorry about that. Specific proportions is what we want. I'm going to do equal proportions in the next example, so hopefully that's okay. So display, yep. Don't uncheck any of these. You're going to want all of them because you're going to want to compare the observed and expecteds. You are going to want to see how each of them contribute so you can tell if there is a difference, who's the biggest and who's the smallest. So leave this as is. It didn't do anything I didn't expect. So here we go. Let's be okay with this. Dun, 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 dun. It does a bunch of stuff. Okay, so if you look over here, you'll notice that it gives you some information about what you inputted. Hey, here's all your categories, here's what you observed, so notice that's coming from our data. Then it has the proportions that you did in the test, so double check these to make sure they match what you're supposed to have. 15, 30, 40, 10, and then 5, just because it did it in that weird order. Then right here is the expected values. So in particular, that tells me that if I had something that was the same size as the number of the I observed in the sample, which in particular is 325, so that's the total of adding all of these together, and took that times 0.15, I would get 48.5. So we expect to have 48.75 condos being sold based on historical values. Clearly those are different. Remember in class we did observed minus expected, squared it, and then divided by expected. Boom, when you do that you get the contributions to chi, which is what this column is. All right, so then when you add up all those contributions to chi, you get the chi-square test statistic, which is just enormous. Anytime this is really big, you should suspect you're going to end up rejecting that hoe. Look how small my p-value is. It's so small it doesn't even want to report it, which is always kinds of fun. Anyway, so here we go. What's the value of the test statistic and the associated p-value? Well, my value for chi-square, and I'm typing that really tiny. I will make that bigger in a minute. Is 62.54. That's super big. And my p-value is less than 100,000th, so I know this is going to be something that I super owe. Actually, that's 100 millionth. And it's going to be reject that hoe. Clearly, there's one of them that's different. Then you look back at your contributions to chi, and you see clearly condos and townhomes are different. So that's what I'm going to write in my conclusion. But I want you to draw your attention to these graphs. Oh my gosh, where are these hiccups coming from? The graph below. So one of the things I talked about in class that I don't think really sunk in is just because you observe a difference doesn't mean it's significant. So if you look at townhomes, like, oh, that's a difference. But because townhomes is so large, remember, this difference isn't that big. But when you look at condos, because there's so much fewer of them, this difference seems larger, and the same thing with homes. So if you look at these, remember expected is the orange, observed is the blue. That means condos is observed higher than what was expected, and towns is low, and homes is lower than expected. So I'm seeing a significant decrease in the number of homes and a significant increase in the number of condos. So if you're somebody who's interested in real estate, this is something that could matter to you and how you would invest. All right, let's write our conclusion reflecting what we just saw. So in particular, there is significant evidence that the real estate sales no longer match the proportions, the historical proportions, that's what I'm trying to say. At least one of the proportion of real estate sales differs from the historical values. I said this a few times in class. It's interesting because in chi, it's powerful enough to tell you, hey, not only is it a significant difference, but here's the two that are the most different. So we're going to add that in with homes being significantly lower and condos being significantly higher. If you want more detail about how much higher and like how big is that difference, you really should use a two proportion test on just those categories. So what I would do is I would take the historical amount for condos and the current amount for condos and do a test comparing those two. So that's one way to get around it. So now we're going to have a little bit of fun, hopefully. So what I decided to do was include something from random.org just to get you used to how you can arrange expected and predicted counts based on using equal proportions. So I'm going to do the same thing, but I'm going to like sample it myself. So we want to see, is this deck of cards that random.org is using fair? So I'm going to take the 4 suits and count them from a random sample of 40 cards. So first I need a random sample. Come on. There we go. Pay no attention to the obscene amount of tabs I have open here. Okay, so in Vegas, one of the things they do is they like to, let me zoom this in a little. Oh, it doesn't zoom the way I expected. All right, forget it. I can't get it to work. Nope, I'm a liar. Okay, they use multiple decks. So if you want, you can make this do multiple decks, which is kind of fun because then you have like the same card appearing 5 times in your deck, but we're not going to do that. I want to draw a sample of 40 cards from one deck. I want to include everything. I don't want jokers. I want to display them face up so that you can see them, and we're going to draw our cards. Bam. All right, I'm now going to pause this video and count how many hearts, diamonds, clubs, and spades I have. Okay, I went through and I've counted, and it appears, where's my Word document? Blanc. I have, when it comes to diamonds, there are 9. When it comes to my clubs, there were also 9. And when I look at my hearts, there are 10. And then my spades had 12. Okay, so I just want to show you this so you can experience how to do this in Minitab. I've got a table. I can just copy it and then paste it into my document and use it, which you can totally do on the homework as well. So now what I'm going to do is I'm going to say my null and alternative hypothesis for this. Remember, we're assuming equal proportions here, so I'm saying that when I look at my 4 suits, they're all equally likely. And since there's 4 options, that's 1/4. So my proportion for hearts is the same as my proportion for clubs, is the same as my proportion for spades. I feel like I'm missing one. Oops, I have 2. Who am I missing? Hearts, clubs, spades, diamonds! They were supposed to be my best friend and never were. I missed a P! All right. 25%, because that's what 1/4 is. Cool. Now, again, for my I'm just going to be rolling with that whole at least one is different thing. At least one suit differs from the others. Others in proportion. Because I don't want to write out all of them. Okay, let's have Minitab produce our counts for us in our expected table. So we're going to go back into Minitab, go to Tables, go to the chi-square goodness of fit test. We again have summarized data in a column. So I'm going to have my observed values as count and suit. And I'm not going to change this. I want to use equal proportion. At this step, we can hit OK because it's going to display everything I want it to. Bam. And here is our chi-square test. So this is kind of fun because here's what we observed, and equal proportion is 25%, and then it produced the expected counts for us, which isn't too much of a shocker. If you're going to assume your 40 cards are divided into 4 groups equally, then you should have 10 in each group. And this can happen. Anytime you have an equal assumption, then it should be all the same. There's one kind of like this in your homework about equal amount of birthdays or pregnancies or something. Children being born. Something with birth. Creepy. Anyway, let's look at our test statistic and our p-value. My chi is not very big for such a large degrees of freedom, so it's not too shocking that I get a large p-value. So my chi stat is, I've called this a bunch of different names on purpose. If you're like, oh, it's got one name, why is she doing so many? No, it has many. That's why I'm doing that. Anyway, p-value is quite large. 8964. So clearly I'm going to fail to reject my null hypothesis. It looks like this card drawing program is fair because, hey, you know, I got everybody equal. So the proportions of the suits are all going to be the same. Come on. The evidence suggests that the suits for the card all appear in equal proportions. Ta-da. Now, if you wanted to, you could say something more specific about how they're each a quarter or something like that. It's the same thing. Yep, so that's about all I've got. If you do end up with raw data where it is just listed in here, like say you've got a column that's just got like A, D, A, B, and you need to organize it some, oh, I have a T in there. You can also go to summary and choose tally and throw that variable in there, and it can give you the counts. So if I needed to have Minitab count something for me, so I could do one of these table options, that's how you would do that. So again, that was summary and then tally. Okay, I hope this video helped, and good luck on your Minitabs.